My name is Tom Dunn. I am a former chair of the Irish Property and Facility Managers Association. I remain a board member of the board of directors of that organisation. In my real life, I'm the head of what's called the School of Surveying and Construction Management at the DIT, where we educate surveyors and people broadly involved in the property industry and also construction managers. So it's my job here this morning to welcome you all and just to welcome you to what is, I understand, the 9th in a series of seminars which has looked at the construction industry from the conception of a project right up to this one, which is looking at FM. And this series will culminate in a meeting, a gathering of CITA, which Alan will talk to you about later on. We have a very interesting morning. Alan, I think, and as a group have put together a very interesting programme this morning, starting in about a couple of minutes with a presentation from Kieran McCrea and Glenda Stanley. Glenda is the energy manager of Vodafone, and she tells me she's an electrical engineer. And Kieran McCrea is the commercial director of Crowley Carbon. And Kieran tells me he's something that might be controversial for FM people later on. So I would encourage him to be as controversial as he possibly can. So would you like to start?
Sure.
I put him on the spot.
Thank you very much.
Is that okay?
Yep. Thanks very much, Tom. So we're going to talk, Glenda and I are going to talk about green mode, or putting buildings into green mode. I'll talk to you about the process and technically what we do, and Glenda will talk to you from a customer's perspective of the resulting energy savings in her Mountain View head office. So I think just before I jump into the presentation, it's probably a good idea to say what is green mode? And green mode is what Crowley Carbon talk about, changing what is normally a static building and making it reactive to its surroundings. So it's about the technology, I suppose both the building management system, the control strategy that goes into that, the field side equipment, and generally the logic how a building is set up so that it can react to its surroundings. So it's a bit like, I'm just looking up here, so we've a low ceiling room, we've about 50 people here, we've fan coils dotted around the place, and what we probably need is about 22 air changes per hour at the moment coming through here to refresh the air. Either that or you're all going to fall asleep in the middle of my presentation or Reed's presentation to follow. However, most of the time I'm sure there isn't this amount of people here, and we probably only need 16 air changes per hour, and then when we go, someone will have to remember to switch it off, or maybe it'll automatically happen at the end of the day. So it's a dynamic environment, and a building needs to react to that. So that's what it's about. So an advert for Crowley Carbon. So who are we? We're an energy services company. We do audits, we design, we project manage, and if we project manage an energy efficiency project in a building, we also guarantee the costs and we guarantee the result, which I think makes us different. So we'll guarantee that you will save X amount of energy per year if you use us. If you have the money to implement that, that's fine. If you don't, we can actually finance the project as well, and we'll do a shared savings scheme with you. So we'll save you whatever it is, 10,000 a year, and we'll take 5,000 a year and use that to pay back the loan under an EPC contract. We also have a product development division, so we have patents in the area of heat recovery, especially contaminated heat recovery, and fossil fuel fired heat pumps. And we have operations in Ireland, the UK, France, Italy, and in Dubai. So that's who we are. These are some of our reference sites. Obviously Vodafone, our favourite client. And we also have a big footprint in the food business. So Dawn Meats there would be our biggest customer. They make all the hamburgers for McDonald's. And the reason food is big for us is because they have huge thermal loads. So there's a lot of hot water being used, and we're particularly good at creating energy efficient hot water. So this is the controversial slide, Tom, that I was talking about. So who's our customer? So our customer is the owner, occupier of a building. And if we can get both, if they're the owner and the occupier, they're our dream customer. If they're just the occupier or the tenant, they're a good customer, but they don't have the same say. So the people that don't care about energy are the developer, the builder, because they're building off like upfront costs, capital costs, built on time to budget. But then once the building is sold on to the owner, they no longer care about the ongoing running costs. And I'm being slightly unfair to FM companies here by putting them in that side of the bracket. And some FM companies are very good at managing energy, but they normally manage the status quo rather than trying to improve the energy footprint of the building. So that's the nub of it. Here's some facts to back me up, just in case you want to attack me later. The US Department of Energy did a survey, and they found only 8% of buildings were commissioned properly. And then the UK government, the Department of Energy and Climate Change, they did a survey, and they found that 90% of buildings had energy-saving equipment cut out of the scope, and it was assumed that that was to reduce cost. So reduce the upfront capital cost, but it increases the ongoing running cost. So this is the nub of it. How do we turn an energy-hungry building into a lean one that's more dynamic and can react to change and actually gives a better quality environment for the occupants? So this is our process. And it's a step-by-step process. So the first thing we do is when we come into a building, we look at the design and what was designed in and what was designed out. We look at how well the building's been maintained. Are the chillers in good running order? Have the filters been changed? All that kind of thing. We then come up with recommendations, and then we implement those recommendations. And at that point, we generally get a good energy saving in the building just by doing that. Then when the building's in good running order, then we implement green mode. So we add loads of temperature sensors, CO2 sensors, VSDs, and all sorts of other equipment. And we improve the energy footprint again of that building. And at that point, we'll probably reduce the energy by 20 to 30% from putting them into green mode. Then if the customer wants to get further energy savings, this is generally a phase 2. We can then look at core pieces of plant equipment and replace that. So if you have a chiller that's more than about 10 years old, we can probably find you a chiller that'll use about 50% of the energy of the one you have. Same with boilers and other pieces of equipment. And then there's a danger once we actually leave a site that the energy footprint starts to increase when just through wear and tear and people setting things to manual override, that kind of thing. So what we have is a carbon control center in Powerscourt House, and we actually can monitor the energy usage, and we can compare one day to another. We can see if the spikes in energy consumption, then we go and look for why that is and try and remedy it. So that's the process. So I'll just jump in then to a little more detail. Obviously time is tight. This presentation normally lasts about an hour, so I'll just fly through it with some examples. So in terms of the building design, what compromises were made in the building? For instance, was there a heat wheel put in? Was there not a heat wheel? Actually, who knows what a heat wheel is? Hands up. Right. Okay, interesting. So a heat wheel is something. If you have an air handling system, you have the exhaust, foul air coming out, you have fresh air coming in. So a heat wheel is something that should be, in my view, by law put into all buildings. It's an aluminium wheel that turns, and it brings, if it's a cold day outside and you have hot exhaust air coming out, it'll take the heat out of the expelled air, bring it over to the incoming air, and it'll heat the incoming air. And that process is about 80% efficient, so there's huge energy savings in that. So most buildings don't have a heat wheel. They've been around for decades, and they just happen to be a little bit expensive, and that's why they're cut out. But it makes a huge difference to your ongoing costs. So it's things like that we're looking for. What technologies weren't available when it was built, if it's an old building, and what's the control philosophy. So here's some examples. I won't go through them all, I'll just pick one. I'm not sure if everyone can see them. Oh. So another example of what we look at in terms of the design is the chiller. So often when a building is designed, the chiller is specified for that building, and then just to put it for a margin of error, it's increased in size by about 30%. And then when you go to the market to actually buy a chiller that's exactly the right size, you might find that there isn't one available exactly that size. You need to buy one just a little bit bigger, and then you'll find that there's a deal on the one that's just a little bit bigger again, and all of a sudden you end up with a chiller that's nearly twice as big as you need, which is fine, and it's great value for money, but it means that it's using twice the power it needs to on an ongoing level. So it's that kind of thing that we're looking at, and we can remedy that. In terms of the operational assessment, that's all about maintenance. What's the condition of the plant equipment? Are there valves, actuators broken? Is there hot water flying through the system when it doesn't need to be, or even more importantly, cold water, because that costs more to produce? And we have a look at that. Here are some more examples. Okay, I'll pick one of these. So chillers running with a low delta T there at the bottom, what that means is if you have a chiller and it's producing cold water, say at 4 degrees, and it's sending it around the building and it's coming back at about 6 degrees, that means very little energy within that water is being consumed, and it's highly inefficient. So what you really want to do is you want to slow the whole thing down. You want to send the water around more slowly, make sure that the cooling is taken out of it and that's coming back at around 10 degrees rather than 6 degrees, and that's way more efficient. And we can remedy that quite quickly. So that's another example of operational improvements. Then we implement the changes, and we have our own preferred contractors, or we can use a customer's existing contractors. In the case of Vodafone, they have their own approved contractors, and we worked with them. That worked very well. We also are familiar with the site, so there's a lot less trouble actually. It went very smoothly. In terms of green mode then, so we have a building that's in good working order. What do we do then? Well, we put in, most importantly, a control philosophy that makes it dynamic. We put in VSDs, we put in CO2 sensors, we put in temperature sensors, and a whole host of different technologies, like hydro mesh, and we can change sometimes the orientation of some of the HVAC systems in the building. Let's see if there's anything else I want to talk about. Yeah, one of the big things we do is we put in compensating circuits. So if and it fixes this low delta T syndrome in chillers. So the sun rises, the best way to explain it is the sun rises in the southeast in the morning, and then it moves throughout the day and it sets in the southwest or the northwest of the building. So different parts of the building are being heated up at different times of the day. So what happens is, if you put in compensating circuits, we can send the cold water to the part of the building where the sun is coming in, and that's way more efficient than sending the cold water around the whole building. And basically then you get a situation where heating and cooling is fighting against each other in places that isn't required. So that's typically what we do. And then moving on, so in terms of a technology update, so we have chillers that I was mentioning are 50% more energy efficient. We have our thermal server, which we call a boiler, that is 80% more efficient. The trick there is we use waste energy and we repurpose it. So it's a type of fossil fuel driven heat pump. And that gives huge savings. In some sites we've managed to actually completely remove the boiler. It's been that successful. And then we have about 2,000 different lighting vendors, and so we can always replace a light in any building. And the good thing about the new bulbs are about a 15-year life, and you can get about an 80% energy reduction. So they're just examples. There's a lot more we do. And then this is the Carbon Control Centre up in Powerscourt. So it doesn't look exactly like that. It will look like that. This is the end game. It's slightly smaller at the moment. But we have customers in England and Ireland, and we're noticing some dramatic increases in energy usage, say on a I'll give you an example. So one of the food companies we're working in, on a Thursday and Friday, their energy footprint almost doubled on the thermal side. So they were using twice as much hot water on a Thursday and Friday. And we had a look at that, and we couldn't figure out, because production levels were the same. So we couldn't understand what it was. And then we figured out that there was a manual system for heating up a hot water tank. And the security guard was in charge of switching it on and switching it off. It wasn't an automated system. So there was a different security guard, basically, on site on a Thursday and Friday, and just left it running all night, so the hot water was just pouring down the drain, and no one knew, and this was going on for years and years, so we saved them a huge amount. So that's one of the successes. The other thing is we have our automated continuous commissioning software, which we install on site, and what it does is it looks at the BMS error log, and it analyzes that, and it can tell you what's wrong with the building or what's about to fail in the building. So it can tell you whether, well, I'll use this as an example again. So you've about 12 fan coil units here. So it'll have a look at that, and it'll say, no matter what time of year, there's always 4 fan coil units heating, even when the majority of the rest of them are in cooling mode. And then it'll say, right, it'll give you a list. It'll say, this month your maintenance guys should have a look at those fan coil units, because they shouldn't be heating all the time. They should be changing, and they're obviously fighting. So they're heating up while these are cooling down. So you get a system that's unbalanced and fighting against each other. So it'll prioritize everything in the building that should be fixed, and it'll prioritize it based on how much money you're losing if you don't fix it. So that's one of the features of the Carbon Control Centre, which customers find very useful. That's it. And can I hand over to you? Sure.
Hi guys, I'm Glenda Stanley. I work as an energy manager in Vodafone. We're based out in Leopardstown. So Crowley Carbon worked on a project to save us energy in our office building. So this is just an overview of the energy that Vodafone uses. So you can see from this that the big red part of the pie chart is our networks. So our main energy user is our network. And then the next highest up is the offices itself. And then our retail stores are quite low. So we're doing energy projects in all these areas, but we focused in on our offices last year and worked with Crowley Carbon. Actually, that picture there is just an energy day we held last year, where we just, for our staff, just educate what we were doing. So Crowley Carbon came in, and that's a turbine that we have on some of our sites, just to show our staff what we're doing, just to make them aware. So I'll just go through quickly like what we're doing on the network and retail side, and then I'll focus in on our office. So in our networks, like we have 2,000 sites, that's why it's such a high consumption. We're swapping out our network equipment at the moment, and it's much more energy efficient, so we actually get much more capacity but still use the same consumption, so that's quite a good achievement. We have our network monitored by a Vodafone product, which is energy data management. So we have like a kind of a subset of our sites, different categories monitored, and then we can use that as a way of predicting what our sites will use. And that's just a screenshot from it, and you can see the drop is when we change to our energy efficient equipment. These are wind turbines that we have on 4 of our sites. There's 2 different designs. The first one is where the cellular antennas are inside the structure, and then the second one, which is a cheaper way of doing it, so you use the existing structure and you just put a turbine on top of it. So we have 4 and we have 3 more planned before the end of March. So they're quite good. They give us, they're still connected to the grid, but you get about 35% of the power supplied by the turbine. In our retail stores at the moment, we're refitting our retail stores. I don't know if you've been in any of them recently, but they've got a kind of a new look to them. And part of that refit, we put in LED lighting. So we're seeing a good result from that. It's given us a lot of energy savings, and we're planning to do all our shops by the end of March 2014. So this is now our office building. So a year or 2 ago, we revamped our whole office building to implement this new ways of working, which is really where nobody has a desk. We all just come in and choose a desk in the morning. Even the CEO doesn't have a desk, so you could be sitting beside her. And this is the look of it, so it looks quite bright and vibrant, and people like it. The main advantage from it, I suppose, was that we use less space, so we could sublet our building. So 35% of our building is now subletted to tenants, and we're getting 40% energy saving from it. So we don't have to pay that 35%, and we're actually more energy efficient in our space because we all have laptops. You have to put your laptop away in your locker every night, so there's no PCs left on, and there's less meeting rooms used because you kind of meet people in these like little areas, kitchen areas and coffee areas. So it's making us more energy efficient as a result. So here's the Crowley Carbon project. So Crowley Carbon came to us in 2012, and they did an assessment of our building. And like Kieran was saying, the way they work is that they do an assessment and they work out how much savings they can achieve, and then they present that to you, and they guarantee that they'll achieve those savings. So they told us that they'd save us 1.4 gigawatt hours by the end of this December, and they could put a monetary value on that based on the unit price. As part of the project, they put in an energy management system, and it has 44 meters around the building, so each chiller and boiler is monitored, and also all the different floor spaces. So we have a clear view of what energy the building is using. So the target line there on that picture, the green line is if we use that much energy, we'll meet our target, but we're actually using less. So we're tracking well ahead of target at the moment. Then also the bottom graph is it shows us how much energy our tenants are using, because they're metered as well. So before we used to just bill our tenants based on floor space, but now we can actually bill them based on how much they're using. So we're actually forcing them to be more energy efficient as well, which is good. Kieran mentioned the automatic continuous commissioning that was put in as part of the project. So it's where you get a monthly report, and it like helps you maintain your energy savings. So it identifies any faults that are in the system, and it prioritizes them based on the money that you're losing by not fixing it. So it's you straight away get things fixed, that are costing you money. So another part of the project was like I don't know if you know the Vodafone building, it's just beside the Leopardstown racecourse. So it's on the roundabout there, so it's a big glass building. So there's an atrium that heats up a lot in the summer, and before there's no air conditioning in the atrium, but before that would heat up, and as you open the doors into the office space, it would suck the cool air out. But what Crowley Carbon implemented as part of the project was these automatic opening vents. So on the top roof there's windows that open, and on the bottom floor, so it creates a little breeze going through the building. So even on the hottest day of last summer, it was a comfortable space to be in. And it's all done based on temperature, so there's sensors and they open automatically, and if it's raining they close and that kind of thing. High winds, it'll close. And this is the Mountain View building, and this is an indication of how much carbon we're saving. So that bubble is how much we're saving per day as a result of this project. And this is we entered the Envirocom Awards. It's a competition by Dún Laoghaire Rathdown Chamber, and we came first in the energy management category. So we're very proud of that. Okay. Yeah. So if you've got any questions, or
I think we might take questions at the end.
okay. All right. Okay.
Questions.
Okay.
Thanks very much for
Friends.
that.
Okay.